Okay, so this little section in the book talks about parameters and it talks about variables. So the important thing here to know about parameters is that parameters are symbolized differently. So here I've got the mean x bar. Sometimes you'll see in textbooks or articles x bar because it's really frustrating to figure out how to do an x bar in Microsoft Word. I did figure it out, but it's also called x bar. So if you hear me talk about x bar, what I'm talking about is the mean, or I'll just probably say the mean, or I might write x bar. Correlations are also represented by the letter R. It's called a correlation coefficient. We'll talk a little bit more about those when we get there. And then you have regression, which is represented by the letter B, and this is known as a regression coefficient. Okay, so Andy goes on and we talk a little bit about, we've said that statistics represent a model. So when you have the mean, okay, the mean, think of your mean as being your model. Okay, so your model is your representation of the population. So when I'm not predicting anything and I'm just saying the average height is 65 inches and I have an error of two inches, right? Because you're not going to perfectly measure a person's height, but that mean of 65 inches is representing the outcome of the average height of people at Hardin-Simmons or females at Hardin-Simmons or whatever it is with an error of 2 standard deviations. So in this particular model, I'm not predicting anything. I'm not using any variables to predict. However, if we want to predict an outcome from the variable, we might have some coefficients that we use to predict the outcome. And so what we do here is we have an outcome that we're predicting. We have this B0 represents when I have no other variables. So say, for instance, if I took out B1 and X1, then that would be the outcome. B0 would represent the outcome, just like it did on the previous slide with the mean. Okay, but however, we're going to add a variable in here that's going to continue to help us to predict that outcome. And then again, we've got a measure of error. So outcome is what we are predicting. Your B0, the value of the outcome with no predictors. All right, so if I didn't have B1 and X1, whatever value I get here is going to represent the outcome. All right. XI, or it's represented by I because you get multiple variables here, is the score on the predictor variable. Okay, so I might have a value of 12, all right? And I'll show you that here in an example. Your B1 is the parameter value that tells us the relationship between the predictor and the outcome. All right, so the computer generates this value here. You are given this value here. And then, of course, we've got error. So let me show you an example here quickly. So let's just assume I have a whole bunch of data and I am predicting emotional intelligence based on a person's GPA. So in this example, I've got an outcome. EQ is emotional intelligence. My 24.3 represents if I did not have a person's GPA, so I didn't know the person's GPA, they would have an emotional intelligence score of 24.3. Okay. However, I'm using GPA as a predictor. So this 0.45, don't worry about where I'm getting these numbers. Okay, I'm just making these numbers up. But this 0.45 represents the relationship between the predictor and the outcome. Okay, so we'll talk a little bit more about relationship, but this number is a number that is generated by SPSS. And my 3.2 is the score of the predictor. All right, so this person, Jane, has a 3.2 GPA. All right, so I'm using these two variables here to predict the outcome of emotional intelligence. Okay, so given my sample, on average, this group's emotional intelligence is 24.3. However, Jane has a 3.2 GPA. It's got a coefficient here of 0.45, which is the relationship between the predictor variable and the outcome. And I've got a level of error of 2.45. Okay, so in this equation, I'm using parameters to predict the outcome. In the previous example, if I had no predictors, your B0 represents the outcome. So the beauty of this is you can add as many variables as you want to predict emotional intelligence. So say, for instance, I'm like, well, GPA predicts emotional intelligence. Maybe gender predicts emotional intelligence. Maybe amount of years of education predicts emotional intelligence. And so you can build out this equation to as many variables as you want, which can potentially drive you insane. So later on, when we talk about which are the best variables to use to predict emotional intelligence, we can say the top three may be gender, GPA, and years of education, even though you've maybe measured a whole lot of other variables. So hopefully that makes a little bit of sense based on the readings and added to those readings.